All right, picking up where we left off last time, we were looking at a transformed variable. So originally we were looking at the gross amount of money that Pete collected from a day trip. And then we looked at the transformed variable, which is his profit, the gross income minus the cost to run the day trip. So we were subtracting 100 from the amount of money he collected. And we learned that when we transform that variable by subtracting 100, our mean shifted by that same amount. Originally it was 500 something, then it became 400 something. But we redrew the shifted histogram and it has exactly the same shape. We recalculated the standard deviation, got exactly the same number. So we now know that transformations on discrete probability distributions look just like transformations on quantitative data. So we're back in unit 1. We're going to review transformations by a constant and then combining two distributions together. And that's the plan for today. We're going to do an example first to warm us up, remind us of what we're doing. So in this problem, there is a histogram and a probability distribution. Oh wait, there's more to this. Where is it? Is it at the bottom of the last page? It must be at the bottom of the last page. There we go. Oh, look at all that. I forgot all of that. Oh my gosh. You guys didn't even stop me. I'm just going to blaze right through it. Review of the rules from yesterday. I add or subtract a constant. What do I do to the mean? I add 5 to the data. What do I do to the mean? Add 5. Yeah. So this is just adding or subtracting the constant. If I add or subtract a constant, like in our last example, we subtracted 100. What does that do to the measure of spread, the standard deviation? I see Vanessa shaking her head. No change. Very good. No change. And we saw in that histogram from our last example, no change in the shape either. Unimodal and approximately symmetric stayed unimodal and approximately symmetric. Good. Multiplying. Similar idea. If I multiply or divide by a constant, the mean responds the same way the individual data values do. I'm going to multiply or divide by the constant. What about the standard deviation? I take all my data values and I double them. What happened to the spread? Double the spread. Yeah, so we multiply or divide by the constant, but there was a limit. There was a constraint here. Standard deviation can only be 0 or positive. I need the, very good, Drew, absolute value of the constant. When I multiply or divide by a constant, do I change the shape of the data statistically? No. Uniform would stay uniform. Unimodal and symmetric would stay unimodal and symmetric. It is a dilation in terms of like math 1 through math 3 because we're stretching or compressing that curve, but it still has one peak and that one peak still in the center. Good. Okay. Now to that example that I started in the middle of because I forgot it started here. So after an exhausting AP statistics study session, you decide to head to Salvati's Pasta Emporium for a yummy bowl of spaghetti. The Pasta Emporium offers 4-ounce, 7-ounce, and 10-ounce bowls of spaghetti. Let S equal the amount of spaghetti in a randomly selected order. Based on historical sales data, the probability distribution of S is shown in the table, which is where the last page picked up. Above is a histogram of the probability distribution. The mean is 6.7 ounces. The standard deviation is 2.1 ounces. To boost sales on an upcoming Tuesday, the restaurant's owners will run a special promotion called 2 Extra Tuesday. Customers receive 2 additional ounces of spaghetti with their order at no additional cost. Let T equal the amount of spaghetti in a randomly selected order on a 2 Extra Tuesday. So we have a distribution for S, stands for the distribution for the amounts of spaghetti in randomly selected orders at this pasta place. Yeah. We want information about the distribution of T, which is the distribution of the amount of pasta in a randomly selected order on 2 Extra Tuesday. What are we doing to get from S to T? What operation mathematically? Discuss with your group mates. Give you 30 seconds. What mathematical operation? All right, Sophia, what'd your group come up with? Adding. Good. What are we adding? Okay, and what are we doing to those numbers in the table? Two additional ounces of spaghetti. Very good. So T is equal to a standard order of spaghetti plus the 2 extra ounces for 2 Extra Tuesday. Yes. So T is S plus 2, which means I am in the adding a constant to my distribution category, which means I know the answers to these questions without having to do a whole lot of math. First, what does the shape of the probability distribution of T look like? So we go to the picture with S. What shape is S? How many peaks? One peak. It's unimodal. Is that peak in the center of the graph? Yes. So this is unimodal and symmetric, which means this is also unimodal and symmetric. Next, they asked us to find the mean for T. If to get from S to T I added 2, how do I get from the mean for S to the mean to T? Yes, very good. So the mean for T is the mean for S plus 2. And they gave us the mean for S. Perfect. 6.7 ounces plus 2 ounces is 8.7 ounces of spaghetti. Happy face. We're all happy when we get extra spaghetti. Yeah. Then it says calculate the standard deviation of T. If I'm adding or subtracting a constant, what happens to the standard deviation? I see a couple of people shaking their head. No, nothing. Yeah. So sigma T is just equal to S, or sigma S. And they gave us that. They said it was 2.1 ounces. Yay. If I had forgotten the rules for transformations on probability distributions, what could I have done? Think back to Pete's Jeep tours. How did we figure out the distribution for B? Good. We literally went through the probability distribution we were given and subtracted 100 from each possible value. We could do the same thing here. We could go through that S table, and for every S value, we could add 2 to turn it into a T value. And then we can use our calculator to find the mean. We can use our calculator to find the standard deviation by running one var stats on that table. Yeah. So if you forget these rules, but they give you the original probability distribution, you're golden. If they don't give you the original distribution, you have to know the rules. That's not a big section of the test, but there's going to be at least one multiple choice question on that multiple choice section that probably has a transformation of a probability distribution or a quantitative variable. This does show up. How many of you have been making flashcards? Show of hands. Okay, so I know some of you have college apps going on, and it's going to be chaos with college apps till December 1st when the UC apps are due. Yeah, after the UC apps are closed, start making your flashcards. Start at Unit 1. Start going through all of the equations, all of the new vocab, all of the big ideas. Because we're going to have a month in April before you test in May to review, but you do not want to have to go through 9 units of material to make flashcards in 4 weeks. You will be unhappy. So start now and baby step it a little bit a week once your college apps are in. Yeah? Okay. So now that we've talked about modifying our distribution by a constant, now we're going to talk about combining random variables. Meaning I have 2 distributions, I want to squish them together. So if we add or subtract 2 random variables, x and y, we do the same thing to the means. Whatever we do to the data values, we do to the means. The mean behaves just like any other data point in the data set. So if I'm adding x and y, I'm adding mu x plus mu y. So mu x plus y is mu x plus mu y. I just add the means separately. What if I'm subtracting the distributions? I'm looking for a difference. We're all so quiet, Addie. If this switches to subtraction, what happens here? Subtract. Yeah. Means are the uncomplicated guys. Add the data, add the means, subtract the data, subtract the means. If we have a linear combination of the 2 variables, a constant times one plus or minus a constant times the other, whatever we did here, we do to the means. So this becomes a times the mean for x plus b times the mean for y. Because the data was ax plus by. I'm replacing x and y with the means. Same for subtraction. A times the mean for x minus b times the mean for y. Whatever we do to the data, we do it to the means as well. Yeah? Doable? We can add and subtract. Good. Let's do an example of when we might see this in the real world. So it says El Dorado Community College has a main campus and a rural campus. The amount spent on tuition by a randomly selected full-time students at the main campus, M, follows a distribution with a mean of $732.50 and a standard deviation of $102.80. The amount spent on tuition by a randomly selected full-time student at the rural campus, R, follows a distribution with a mean of $825 and a standard deviation of $126.50. Let D equal M minus R. Calculate and interpret the mean of D. Before we answer the question, which is calculate and interpret the mean for D, we need a conceptual understanding of what the heck D is. So I want you to take about 90 seconds in your group and describe to me in words what the distribution of D represents. All right. All right, Jaden, what does your table think? What does D represent in words? Which campus? It's okay. I appreciate that you tried. Can somebody help Jaden out? What does D represent? In? Between what? How what? Difference between the campuses. What about the campuses? Tuition. There we go. It's a difference in tuition between the main campus and the rural campus. And it specifically is main minus rural. So I'm looking at how much more or less the rural kids spend versus the main campus kids. Good. They ask us to calculate the mean. So I want the mean for D, which I know is the mean of M minus R. How am I going to find that? Raise your hand if you know. Yes, Drew. Mean of M, mean of R. Subtract them. Raise your hand if you agree. I see thumbs up and hands. Very good. And they gave us both of those. They were nice. They said the main campus has a mean of 732.50, and the rural campus has a mean of 825. And I do not want to do that in my head. So negative 92.5. Confirmation? Yes? I shouldn't put that there yet. Negative 92.50, since we're talking about money. I agree. Before we interpret, on average, who pays more, the main campus or the rural? The rural. Good. I got a negative answer. So the second number must have been bigger than the first when I subtracted. So rural campus on average is spending more on tuition by that much. So the difference in full-time tuition between the main campus and the rural campus is negative 92.50 on average. So on average, the main campus full-timers are paying a little less than 100 fewer than what the rural campus kids are paying. Which is a little backwards when you think about how community colleges work. Doable? No. Questions? No. Okay. We'll keep rolling. All right, the other thing we have to talk about is the spread. We know how to deal with the center. Whatever we did to the variables, we do them to the centers. Standard deviation is a little different. First, there is a condition. In order for the formulas I'm about to plop up there to work, the random variables x and y must be independent. Independent. Yes, I know how to spell. So take a couple seconds in your small group and discuss. We talked about what it means for two things to be independent in terms of probability. Discuss. What does it mean? I'll give you about 60 seconds. Get a random name ready to go. That's, yeah, give us the real world implications and not the formula. Okay. Jacob, what does it mean for two things to be independent when we're talking about probability? Very good. So knowing that A happened doesn't affect the chances that B is going to happen. The fact that B happened doesn't affect the chances that A is going to happen. Good. Very good. So we need things that in the real world don't affect each other. Yeah. If that's true, then the formula for the standard deviation is the square root of the sum of the squares of the original standard deviations. Looks gross, but we've seen it before. We saw it when we did this for a list of quantitative data. It's the same rule. Combining distributions, square root, sum of the squares. Yeah. And here comes the weird part. Even if I'm subtracting x minus y, this is still a sum of the squares. Standard deviation doesn't get smaller. It should never be less than 0. I squish those distributions together. Their standard deviations are going to combine to make it either more spread out. It's not going to get less spread out. And then we get really weird. If I have a linear combination of x and y, constant times x plus a constant times y, similar idea, but in addition to squaring the standard deviations, I now square the constants too. Highly unlikely you will see that on the AP test, but if you do, square the constant along with the standard deviation. It is important to keep in your mind that when we're adding and subtracting, the mean follows that sign change. Standard deviation will always stay plus. It's always going to stay a sum. Okay, let's go back to our El Dorado Community College example. So we're back at our El Dorado Community College example. We looked at the distribution of tuition, main campus, rural campus. We're looking at the new random variable, which is the difference between main versus rural. And A says, explain why it is reasonable to view M and R as independent random variables. take about 90 seconds in your small group and discuss what real world justification could we give to argue that M and R are independent. Why are main campus tuition and rural campus tuition independent? Why are they not paying the same amount? What do we know about the students who go to those campuses? Are they the same student body at both campuses? No. Different students, same distribution of majors? Probably not. Yeah. So different students, different course loads, different majors, different. Yeah. So we would not expect them to be connected. We look wide awake and perky at this table today. Are we feeling okay? Yeah. Do we have any ideas on why they might be independent? On different campuses, yeah, and different students and different, yeah. Good. Good. All right, volunteers, who wants to share why these are independent? Frowny face. Frowny face. Yeah, Shari. Yeah. Effectively, these are separate populations. It is unlikely that there is a student who is attending both the rural campus and the main campus. They're going to go to the campus that is closest to them. And so I expect that they are behaving independently. I don't have any students who are at both, so knowing what's going on at one campus isn't going to tell me what's happening with students at the other campus or how much they're paying. Totally, completely separate, independently functioning campuses with their own student bodies. Knowing that they're independent, or feeling confident that we can argue they are independent, we are asked to calculate and interpret their standard deviation. So I want standard deviation of the difference, standard deviation of M minus R. And we know when we're combining distributions, it's the square root of the sum of the squares. Square root of the sum of the squares. Square root of the sum of the squares. And they were giving us sigma M and sigma R. We have the standard deviations for the main campus and the rural campus independently. What was the standard deviation on the main campus? Whoops. 102.8 squared plus, and then rural is 126.50 squared. And then we grab our handy dandy calculator to do that math for us. And I get 163. So what that's telling us is that the average difference in tuition between main campus and rural campus varies from that negative $92.50 by about $150, $163 if we want to be exact. Meaning, because this standard deviation is bigger than my mean, there are some students where main campus is paying more than rural. But most main campus is paying less than rural. Because most of that peak, that one standard deviation on either side is negative. Yeah. Yay. Okay. Questions on the notes? No. You will notice on the back or the bottom, there is one more question. That is a check for understanding for the whole section of notes we've taken over the last 2 days. Yeah. Do I have somebody who has a nice loud voice who'd be willing to read up to question 1 for us? Thank you, Drew.
A large auto dealership keeps track of sales and lease agreements made during each hour of the day. Let X equal the number of cars sold during the first hour of business on a randomly selected Friday. Based on previous records, the probability distribution of X is as follows. Suppose the dealership's manager receives a $500 bonus for each car sold. Let C equal the bonus received from the car sales during the first hour on a randomly selected Friday.
Very good. Thank you, Drew. So we're given a distribution of the number of cars sold during the first hour. We're asked about a distribution of the bonus that the sales manager earns for those sales. So the question is, how do I get from the distribution of number of cars to amount of bonus? And you'll notice it's $500 bonus per car. How would I figure out his total bonus? Yeah, give me an exact formula. How would I find how much he earns? Yeah, multiplication is faster. You're right. It would be 500 plus 500 plus 500, but I need to write it in terms of a variable. So multiplication would be shorthand. Yeah. So the amount of bonus that they earn for car sales is just $500 times the number of cars that were sold. You will notice I did that before I even started reading what the questions are, because I can't answer questions about C until I know what it looks like in relation to X. I have to know what the new looks like in terms of the old before I touch anything else. All right, number 1, write a formula that expresses the random variable C in terms of X. Hey, we just did that because that should always be the first step in these kinds of problems. Relate the variables. Explain why the probability distributions of C and X have the same shape. So what are we doing to get from X to C? Multiplying by a constant. And we know multiplying by a constant shifts the mean. Yeah? It changes the standard deviation, but it doesn't change the overall shape. Symmetric will still be symmetric. So no change in shape. Next question says, find the mean for C. How do I find mu sub C? Yes. 500 times the mean for X. Yeah. Whatever I do to the data values, I do them to the mean. So 500 times the mean for X, and they gave us the mean for X. They said that was 1.1. Whoops, I don't know why I can't write that when I said it right. There we go. 500 times 1.1. I'm pretty sure that that's going to be 550. assuming I can do math in my head this afternoon. I don't see any argument. I see some nodding. Good. Last one says calculate, interpret the standard deviation for C. So we want sigma sub C. If I am multiplying by a constant, what happens to standard deviation? Multiply by the constant. Good. We have to make sure the constant's positive. This one is, so no worries. So 500 times sigma x, and sigma x is 0.943. So 470, 150. So the average bonus varies from the mean by about 470, 150. Meaning a decent chunk of the data in terms of this manager's bonus is a little bit less than 100 to a little bit over 1,000. He's somewhere in that range. So far, so good? Good. I need somebody who hasn't read yet to read the next chunk up to number 4. Volunteer? Thank you, Yari.
Let y equal the number of cars leased during the first hour of business on randomly selected cars. Based on previous records, the probability distribution y has made 0.7 and standard deviation of 0.64. It is safe to assume that x and y are independent to find t equals x.
Thank you, Yari. Before we answer number 4, Chris and Jacob, I have passes for you for the Career Center. Okay, number 4. Based on what Yari said, they've given us a new variable t. Yes? T is x plus y. X was number of cars sold. Y is number of cars leased. Yes? T is x plus y. It says find and interpret the expected value. The expected value has another term that goes with it. Expected value is also known as the what? The mean, yeah. You're looking for the mean of t. For probability distributions, expected value is another word for the mean. Yeah. I know that this is mu x plus y. How do I find that value? Valeria, how do I find that value? What do I do? What did I do to the variables? I added them. What should I do with their means? Add them. Yes, very good. Mu x plus mu y. We know that mu x was 1.1. I see nodding. And we know that y is 0.7. So this would be 1.8. 1.8 what? What are we counting with x and y? What physical thing? Cars. Cars, yeah, cars sold or leased. 1.8 cars. So not quite 2. On average, not quite 2 cars are leased or sold in the first hour. Which makes sense. Most people don't get up at the crack of dawn to go buy a car. That's not like a morning activity. Okay, next one says calculate sigma t. Calculate the standard deviation. So sigma t is sigma x plus y. And when I am adding standard variables, or random variables rather, what happens with their standard deviations? Who can tell me? You wrote it down. It's on your paper in front of you. It's not a quiz or a test. Square root of the sum of the squares. Yeah, square root of the sum of the squares. Yeah. So we know the standard deviation for x was 0.943. You did that correctly. Squared plus standard deviation for y is 0.64 squared. I get 1.14 rounded, and I see some nodding. 1.14 what? Cars. Yeah, we're still looking at number of cars. So on an average day, I'm somewhere between 0.6-ish cars and almost 3 cars. Yeah, within about 1 standard deviation on either side. Yeah, good. Last question. Dealership's manager receives a $300 bonus for each car leased. Find the mean and standard deviation of the manager's total bonus B. Total bonus B. So we have half of this equation already set up. When he sells a car, his bonus is 500 times the number of cars he sold. Now I want to include in that number the amount he makes from leasing a car. How much money is he going to make from leasing cars? 300 per car times, right, the number of cars that I leased. Yeah. A linear combination of x and y. And you will notice that it asks you to find the mean and standard deviation for that new distribution B. I'm going to give you just about 2.5 minutes in your small groups, and then I'm going to randomly select 2 people to either come up to the board and do it or walk me through how to do it. So I'll give you about 2.5 minutes. If you're pacing yourself, I already found the answer on my calculator. So we need to practice our speed. My mom used to have a bunch of those. She'd give them out to her nursing students. Are you thinking about going into a medical profession? Nice. So the formulas for both those questions in the last part are on the previous page. What do we do for the mean? What do we do for the standard deviation? So that's what we do for the standard deviation. Page before that has the mean. Yeah? Good? All right, we're going to start with the mean. And I'm going to pick on Ivan because I walked by his table and saw he got the right answer. So define the mean for B. Ivan, what did you do? And what did you get? Can I get a thumbs up if you agree? Very good. Very good, Ivan. So we know it's just A times the mean for X plus B times the mean for Y. Whatever we did to X and Y, we do it to the means. Good. We also want the standard deviation for B. Somebody other than Ivan, you have an answer for the standard deviation, can walk me through it. Yes, Drew.
It would be 500 times the standard deviation of X plus 300 times the standard deviation of S. The cars sold in the standard deviation of cars sold. Sorry,
No, that's okay. I've done this a couple times, so I think I have the numbers in my head. Thumbs up if you agree. Everybody who just gave me a thumbs up gets an F for the day. Remember, when you're combining variables, not constants, but variables, X and Y, square, 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 square root. Remember, if we're looking at standard deviation, it's not affected by addition or subtraction when it's standard deviation plus or minus a constant, right? That doesn't shift it. It only shifts when there's a second variable being added in, and that makes everything lighter. When I did it, I got 509.09. Somebody should check my math on that. I'm getting some nodding from the back row and thumbs up. Thank you, thank you, thank you. So, the big question is, as that on here, because this is your friend. And looking at your equation sheet, that is not on here. The directions to find the mean and standard deviation for a random probability distribution are on there. X times P of X, right? X minus the mean squared times P of X. All of that's on here. But the transformation of variables is not on here. That's note card worthy. That's something we should invest some memory space in. Yeah? Okay. I'm going to give you about 3 minutes. And in that 3 minutes, you need to put your notes away. You need to get out a blank sheet of paper and something to write with.